Let's take the case of a 4 kilogram block with an initial velocity of 10 meters per second that is colliding with a 6 kilogram block that is stationary. After the collision, the 6 kilogram block is seen to be moving at 5 meters per second. Your job is to determine the velocity of the 4 kilogram block after the collision. Final velocity. Solving for this after they collide somewhere right here. Momentum is always conserved, meaning we add up the beginning momentum, it should equal the final momentum. And momentum is a vector. This shows that momentum is a vector. That the half arrow shows that it's a vector. P is momentum, M is mass, and V is velocity. Momentums have to equal, meaning the momentum of the first object and the momentum of the second object added together in the beginning has to equal the momentum of the first object and the momentum of the second object added together at the end. So this, you can see that with this mass 1 and velocity times velocity 1 initial plus mass 2 velocity 2 initial has to equal mass 1 velocity 1 final and mass 2 velocity 2 final. So the momentum of this at the beginning has to equal the momentum of this at the end. So let's just set up the equation. Mass 1 times velocity 1 initial plus mass 2 velocity 2 initial has to equal mass 1 velocity 1 and mass 2 velocity 2. Okay. We plug in what we know. Mass 1 is 4, velocity for the first object 10, and you add it with the mass times velocity of the second object, or the momentum of the second object. And it's not moving, so the velocity is 0. 6 times 0 equals 0. Okay, so now we have to find the end velocity of the 4 kilogram cart. So just keep plugging in what we know. The mass of the first object stays the same, but now we don't know what the velocity is. That's what we're solving for. Plus, now the 6 kilogram cart is moving at 8 meters per second. That's its new velocity. So when we do the math, this is 40 plus 0 equals 4. This is initial. This is final. The 4 VI V1 final plus 6 times 8. Subtract 48 that equals negative 8 plus 0 equals 4 v1 v1. I guess you can stop putting the f because you might get confused with the 1 and you might get that confused. That's a 1, not an I. A 1. So now this is basically just negative 8, and that equals 4 v1, and you divide it by 4. Negative 2 equals v I. So going back to the question, the final velocity for the 4 kilogram cart equals to negative 2, and we can check this. We can rewrite the equation. Mass 1 v1 plus mass 2 v2 initial, and it has to equal mass 1 v1, plus mass 2 v2 final. Okay, so we know that the masses for the first is 4, and then its initial velocity is 10, and the mass of the second object is 6, and then the velocity is 0, and the mass of the first object is still 4. But now we found out that the final velocity for the 4 kilogram object is negative 2. We know that the mass is 6, whereas the object is 6, and its final velocity is all. Momentum has to be conserved. So when we do our math, this is 40 plus 0 equals to negative 8 plus 48, and it equals negative 8 plus 48 equals 40. So, and with this you can see that momentum was conserved. E1 final